Go.
Hello, good morning, good afternoon, good evening, wherever you are. My name is Carlo Longino. I'm from WIT, and I'm here hosting today our developer Smackdown about Arduino. I'm joined by a few developers from around the world who are going to show us some of the cool things that they're doing with the Arduino platform today. So we're excited to have them with us and see what they come up with. Up first, I'd just like to ask the developers to take a minute and tell us who they are, introduce themselves, a little bit about what they do. So up first from Barcelona, we've got Oscar Martinez. So Oscar, welcome, and why don't you tell us a little bit about yourself?
Well, I'm a sound engineer from Barcelona, and I'm really passionate about building instruments. That's my main focus on Arduino hobbies, development. It's around building instruments, musical instruments. And I will show you in a while with some of my invention. Well, that's almost it. I don't know. Thanks.
Thank you for joining us today. Sudar, welcome. Tell us a little bit about yourself.
Hey guys, so my name is Sudar. I'm from Bangalore, India. I'm a web programmer by profession, and Arduino is my hobby. I've been playing around with Arduino for maybe around like 3 to 4 years right now, and one of the things which I created with Arduino, which I'm going to showcase today, is something called Arduino Makefile, which is a makefile which I created for Arduino that allows you to use any IDE and still program Arduino using a makefile.
Ooh, that's nice.
All right. It sounds exciting already. So the way the Smackdowns work, just in case someone hasn't joined us before, each developer will get 3 minutes to show us their project or their code trick, and then we'll have a minute or so if there are any questions, anything like that, and then at the end we'll judge. And the winner today will be receiving a SparkFun gift card. So high stakes to grab some more Arduino sensors or tools or boards or anything you like from SparkFun. So we should have another developer joining us. He was running a few minutes late, but we'll go ahead and get started. Oscar, you're going to be up first. So if you want to get yourself ready and everything, we'll throw it over to you to kick us off.
Yeah, whenever you want. I should share. I should screen share.
Okay.
Right? Just for show you my code. I have here the Arduino. Well, it will be short, just a little bit of code, and I don't know. Is it working? Hi.
Yep, we can see your screen. I see myself.
Okay, let me grab the Arduino environment. Something this one here. It was open. Now I can. Oh. Well, I will open it with Sublime Text instead. Yeah. And can you read it? Good enough. Syntax C++.
So a little bit.
Yeah, if you could make it a bit bigger, that would be great.
Let me see. Do you know, guys, how to do it? How to do so on here on how do you call it? Uh, mm, oh, I forgot the name. Sublime text. Yeah, to make the screen look bigger. I'm using Windows computers, so I don't have the. I don't know. You can you read it? Don't you? Is it possible?
Difficult.
What?
Better. No?
Bit better. I don't know how to make it bigger. Let me see on tools, maybe. You read it?
Well, it's fine. Just go ahead.
Okay. So my time's running. It's running now. Okay. So I just want to show you really briefly a library, a subset of objects I've been working for when I use that I use when I build my instruments, and they make it a bit faster, turning an analog input range into something that you can map, make it sound on different notes and scales and all that. I don't know. Here at the top, just the typical includes for the library, but the most important thing is actually these three lines. The other thing is just like setting up the objects. Here, you got the typical range that you get when you read an analog input on Arduino. You get a number between 0 and 1023. And then by using this object, I don't know if you can read it, here the RTP smart range thing. What it does, it gives you the number of zones depending on the position of the reading that you are inputting. It gives you like different zones or different steps. And in the end, I don't know if the code makes any sense now, because but if I can show you. Do you see? Can you guys see the camera? Oh, what you seeing now?
See your desktop.
Okay, and now you're seeing my camera, the image camera. No.
Still your screen sharing.
Now?
Nothing. There you go. Okay.
Yeah. Okay. This is the thing I wanted to show you. That's the code. Sorry. Here is a. Can you read?
You can sort of see it. Looks like you've got a flex sensor.
Yeah, this is
I'm having a hard time hearing.
yeah, so I don't know, like, internet connection, I don't know if it's working or not. But, sorry. This is really hard. Can you hear anything? No?
I can hear you a bit more clearly now. Not hearing. Oh yeah, there we go.
Okay, this is the thing that is on the code, and the other thing I wanted to show you is one of the instruments I have is this guy here. It has, actually I have two of them. Here is, it has like this matrix LED thing for building like a sequencer, and also you have here, I don't know if you can see it, three distance sensors. And with that you can create like, okay. Can you hear the music?
Yep. All right.
And
what I up was far, but that's
okay. Sorry.
Cool. Thank you for sharing that with us.
Okay.
Looks good. All right,
Okay.
Sudar, if you're ready, it's time to see your code trick.
Sure. So before that, I'll probably just give a brief introduction about um, what I'm going to be talking about today.
Yeah, perfect.
Um, so most of the people who have probably like started working with Arduino would have realized that the good thing as well as the bad thing about Arduino is the IDE, right? So when you're just getting started, uh, using Arduino IDE is way easier. You can just get started. The barrier to entry is very less. But what happens is, like, after some time, once you start working with Arduino for quite some time, the Arduino IDE can be quite limiting. Uh, by limiting, I mean that any programmer would have his own um, preference for an IDE. So personally, I use Vim for everything, but like Oscar was using Sublime Text, and like if you get into a room of developers, 10 developers, then there will be, like, 10 different IDEs which each one of them would want to work with. So the problem with that is that the Arduino IDE can be very limiting at times. So what I have created is a makefile for Arduino, and this has been something which I've been working on for quite some time. Um, I think you will all be able to see my screen now. Are you?
Nope.
Not yet. Okay, you are. You should be able to see my screen now. Yes.
Yep. There we go. Got it.
Okay. Yep. Great. So this is the project which I was talking about. So this is there. So the entire code is there in GitHub, so you can check it out. And so the important thing about this project is that you don't have to make any changes to your existing code. If you already have any Arduino code which you've created, you can just use that, and it would be possible for you to run that code. So the makefile would allow you to compile the code, would upload it directly to your board. You can also do debugging. You can use serial monitor, pretty much everything. Pretty much any feature which you can use with the Arduino IDE, you will be able to use it with the makefile itself. It's a complete package which allows you to do that. I won't go through all the details in the documentation, but the important thing is that there are packages available for pretty much all operating system. If you're using Ubuntu or if you're using Mac, you can use it using Homebrew and things like that. So I will show you a quick demo of how this works. So there we go. Okay, I'll first show you a um, very simple example. So this is the Blink program, which pretty much anybody would have started with Arduino would have started with the Blink program. So this is the code. Okay, and to compile this using makefile, all you need is just only this one. You basically need to specify what is the board you're using and the port in which your Arduino is connected, and if you have any libraries, you can specify them and then include the master makefile. I'll show you a example here. So here you can see that I have both the Arduino script as well as the makefile. All I need to do is just make, and then it'll basically first print out all the different parameters that I've taken in, and then it will compile the code and then give it to you. So once the code is compiled, I have not connected Arduino to my computer right now, but once I've connected, all I need to do is just type make upload. It will upload the code to Arduino, and if I have to do any serial monitoring, then I just have to say new. So pretty much anything which I want to do with Arduino, I can do with this makefile, and you can use your own IDE for that. And
Fantastic.
that's what I had to show today.
Great. That's impressive. Thanks for sharing that with us. It looks like in the meantime we've been joined by Jan from Belgium. Hi there, Jan.
Hello, can you hear me?
You're a little quiet.
I'm a little bit quiet, yeah. I haven't been using this system a lot for video and stuff like that. I would like to.
If you just want to, if you just want to take a minute and introduce yourself and tell us a little bit about what you do, and then yeah, if you want to show us your code trick, that would be great.
I'm an IT architect. I work for IBM and I've been busy in the open source. I've written the Arduino Eclipse plugin for developing Arduino with Eclipse. But here specifically, I want to show some code in regards to enabling Arduino and the internet. So I've sent you a link in my last mail. If you would mind opening it and showing it.
Alfonso.
Sure. Yep.
Did you find the link?
What? Excuse me?
Did you find the link? Or, oh no, you just find stuff now. Okay, I actually wanted you to, I'll open this one here.
Link. Oh. Okay, this is the link.
So, can you, how do I share my screen here?
Can
you tell me how to share my screen?
Yeah, left icon.
Screen share.
Yep.
Screen. This is here. This is the Arduino. There's an HTML page from the Arduino, and it's actually a very simple calculator. And it adds the two numbers, so adding 23 to 4 equals 447. Yeah. If we look at the code for this is the code. This is really slow. So this is all the code. What I have is I use a library. I have 4 serial channels, one for input, one for output, one for error, which are all pointing to the same channel to go to the unit. This is the name for my program. Here I store some information, and I have sum value 1 and value 2, which will do the calculation. This is the part which goes to connection to the unit. This is very general code you need for the unit. And then here, this is a very important piece of code, because here I actually link the HTML to the variables. So here you see value 1, which is the value which you saw on the screen, and adding 2 gives and sum. So if we go back to the browser, here you see sum, adding 2. So this is value 1, this is value 2, and this is sum. Here, this is all you need to link it, and this is the whole loop. Yeah. And this way of working can be done to do more complex things. So I upload the other demo. So what you see here is the Arduino Eclipse plugin, which I use to, so now compiled. My system is extremely slow. Yeah. It's so slow, I started it 2 times and it won't work anymore. Yeah, sorry. But the code, I can show you the code here. which is actually for blinking LEDs, and it's very, very, very similar. Oh, it's working now. Which is very similar to the previous one. So I actually started from the NeoPixel example. This is nearly all the same as NeoPixel. This is again the same stuff we saw previous time. Here we have the array, and here we have red, green, blue variables, and we get the color, and we have the serial register to that. And here we just register the stuff, and this is the whole loop. Again, very, very, very simple, and it allows us to change the here 200, and if you now go here, can I see myself here? No. Can you? I stopped sharing my screen. Oops, what's going on here?
Infinite screen share.
How is that going?
It's still going. There we go.
Okay. Now you see here the red dot.
Yep.
That's the LED which I turned on just now.
Okay.
If you go to the web page, every pixel can be changed in any color. And I send you the link, Carlo. So you can do it from your site. You can change the LED behind you.
Okay, cool. So basically then what you, I see let's see here. Let's see if I can make this work. So we've got
you turned on
green now. Let's see if I go 0, green, and then 5 blue.
The other people can see it here behind me. Here, the LED now burning, which is being controlled over the web.
Yep. Okay. And then
there's 5 pixels, and you can change every pixel.
Okay. Cool.
Tabs, so you can change every pixel.
Okay. Yeah. Okay. So then really you could use this to control sort of almost anything over the web, whether it's just an LED or whether it's a pump or a control of some other kind or something.
You control the variables in your Arduino. You can create any variable which you can share over the internet in text format, and you can just control them over the internet with your Arduino.
Okay, cool.
Just like that. It's very, very, very simple.
Great. All right. Thanks for sharing that with us, Jan.
Yeah,
so we'll take a couple minutes here for our panel of experts to deliberate and choose a winner. In the meantime, if you guys have any questions or feedback about each other's code, I think it'd be great to see that. Oscar, any comments or questions for Jan or Sudar?
So, which Arduino are you using? Are you using Arduino Uno?
Me? Can you hear me?
Yeah, basically I was asking you which Arduino are you using? Are you using, there are different types of Arduino, right? Uno,
Yeah, I know.
Mega.
Can you hear me?
Yes.
Yeah.
Yes.
Okay, nice. Okay. Yeah, actually, here, the first I showed you was a plain Arduino Uno, but on the other hacks I use a Teensy, which I've seen you support, and this is awesome because I really like Teensy. So I've seen you, Sudar, that your makefile works with Teensy, and I'm a really fan of Teensy, which I also use because it's really powerful. Teensy 3.1, so great for giving support to that. Yeah.
Yep.
I really like you both projects. They're really awesome. And one thing I want to use is the Sudar's makefile thing, because I feel trapped sometimes on Arduino IDE, because as you said, it makes very easy to start and doing things, but when your project gets a little bit more complicated. You have like more dependencies, more files. You get like, oh, this is so simple. And I've been looking for something like that. Maybe for Xcode, it can work on Xcode. Does it? Do that? For example.
Yes. So basically, this makefile is independent of the IDE, and what you can do is like you can edit the code in Xcode, and then configure Xcode to just call the makefile. And when you do that, you will be able to use Xcode, Eclipse, any IDE to program Arduino. All you need to do is like that IDE specific configuration to just use this makefile. And the other thing is like you can also use this makefile to combine, let's say if you have plain AVRC code which is not Arduino compliant, you can still, if you have like a C library which you want to use in your code, you could still use it using this makefile.
Gotcha. And I don't know, Dan, what's your name?
Jan?
So with that you can control whatever, even I2C devices through the website.
Yeah, you can.
Whatever.
Yeah, because you actually can change and the variables in your program. Yeah. So if you, for instance, what I do is I have a robot, a lawn mowing robot, which is running around in my garden, and I fully control the robot over the web. There is basically only an on-off switch on the robot. Yeah. So there's I2C devices in there, there's sound in there, there's GPS in there, everything's in there, and I can, whatever I want to control, because you have to specify whether you want to control it or not. Everything I want to control, I can control, and basically you can change the variable, and that way you can, if you, for instance, if you want to detect a variable had changed, you just create two instances of the variable. One is called new value, and the other one is current value, and you only let the new value to be changed, and then you just check new value versus current value, and you know it has changed. Yeah. And it's very simple. Like the insight is very complex, but usage is very simple.
And you need to have your Arduino connected to the computer that acts as a gateway through the internet?
I'm using, yeah, here in this example, what you see here is a unit. Let's grab it. This is, a unit. Oops.
Arduino unit, okay.
The Arduino unit, and there is just some LEDs connected to it. Yeah. So the unit is a Linux already.
Yeah, I've heard of it.
Any Linux box should do. If you, I've done it with an open VRT router, yeah, and that works fine too. But the unit is very easy to use.
Okay. Thanks.
All right, fantastic. So I understand from our expert panel of judges, it's been a very difficult decision today. But in the end, the prize, Jan. So fantastic. We've got a gift card or a gift certificate for SparkFun for you, so you can buy some more cool things for your Arduino projects. So thank you very much to Jan, and congratulations on winning today's Smackdown. Oscar from Barcelona, thank you for joining in, and thanks for sharing your cool music projects with us. With another Smackdown, and this one will be focused on the Swift programming language, so be sure and tune in for that. So thanks again to our developers for taking part, to Samsung, our sponsor for today, and this is Carlo from WIP signing off, and we'll see you next time.